What's up, YouTube? I'm here again with a chance to interview another peer that works for a company called Sierra Nevada Corporation. And this is a privately held aerospace contractor located in Sparks, Nevada. But they have 33 locations nationwide, as well as some locations in the United Kingdom and Germany and a few other countries. And this company specializes in developing space components and other aerospace avionics or integration components for the aerospace industry. They've worked with companies like NASA and other private space companies, including the U.S. Armed Forces. And I look forward to interviewing this peer, so stay tuned because I got some good content. Sierra Nevada Corporation is a private aerospace contractor known for developing space components and performing aircraft modification and integration. Within their space division, they develop satellite technology and perform satellite operations. They have also developed mechanical and structural components to support NASA's Mars rover mission. Their most noteworthy project is the Dream Chaser, which is a reusable lifting body space plane. The Dream Chaser is designed to carry both cargo and people to the International Space Station. The Dream Chaser is intended to launch vertically on the Vulcan Centaur rocket and will autonomously land horizontally on a conventional runway. Overall, Sierra Nevada Corporation has been involved in over 400 successful space missions. Before I get to the interview, if you guys could hit the like and subscribe button, I would greatly appreciate that. But stay tuned because I got some good content ahead. What's up, YouTube? I got a peer here who I'm going to be able to. I'm excited to interview today. This is a colleague from college, and I'll allow him to introduce himself. So, but even if you can introduce yourself by stating your name, where you're from, and your official job title, I really appreciate that.
Yeah. Hello, thank you for having me on here. My name is Ibe Morrissey. Born and raised in Syracuse, New York, and I went to school, Syracuse University. I have an undergrad from there. That's the only degree I have, and aerospace engineering. And my job title right now, I'm a mechanical engineer at Sierra Space, formerly known as Sierra Nevada Corporation. They're headquartered in Nevada, and I work in Colorado.
Awesome. So you're a mechanical design engineer. That was your official title.
I'm the official title is a mechanical engineer 3.
Okay.
But I do design engineering. Yeah.
Awesome. Okay. So yeah, I was looking at your company, Sierra Nevada Corporation. It sounds like you guys are doing some rebranding. So given can you describe your day-to-day duties in terms of what is a mechanical engineer at your company typically do on a day-to-day basis in terms of just like, are you more of at your desk, at your computer? Do you do full investigations? Can you kind of just in detail kind of describe what your day-to-day duties are?
Yeah, so mostly a desk job. So there's multiple buildings on the campus area. One of them is the production floor. The production floor is where most of the mechanical engineers sit, as well as structural engineers. The structural engineers, they do the analysis on the designs. And I guess my day-to-day is I go in, I do a French press of coffee, and no.
I get coffee too. You know, I won't lie.
Yeah, I sit down on my computer, and I do CAD modeling. So the advantage that I have is I sit at the production facility. So any of the designs that I do, I can walk over to the manufacturing floor and talk to the technicians who are assembling it, talk to the manufacturing engineers who are working with the technicians, talk to the liaisons, try to understand, what worked and what didn't work to make designs better in the future. But I heavily involved with NX, the CAD system that we use, and I guess kind of stuff that goes on in the background of my head is I have to interface a lot heavily with all the different types of disciplines out there. So your thermal engineers, the routing engineers, the electrical folks, the strength analysts, the material engineers. I need to understand what stuff that they're doing, stuff that they're working on, and how to factor in, their opinion about my design. So I'll like design something and I'll throw it by them. Like the strength analyst, he'll do like a preliminary type of calculation, and then he'll give me his feedback, and then I run it by a few other engineers, see how it works. And then another aspect of my job is I can do simple like hand calcs or analysis on like Excel. Uh, all the all the skills and knowledge that you learn in school, it's very applicable to everyday job that I do. So a lot of different stuff.
So that's very interesting. So I know you said you're a mechanical engineer. Which department are you in? Do you do sub-assemblies for a specific aerospace system, or which department? I'm in the airframe division in my group for we do Predator drones, so we do airframe design.
Yeah. So I'm currently right now I'm working on like secondary hardware. Like an example of a project that I'm working. It's not classified information. There's proprietary information, but there's a huge tank inside of the spaceship, and it has propellant in it. So there has to be a structure that holds up this tank and takes the load and distributes it. So I have to design different types, titanium, composite, stainless steel, and aluminum, just different components that hold that, as well as there's a bunch of electrical boxes and batteries that need to be supported on the actual primary structure. So that's what I do.
Wow, man, that's pretty cool, man. Working on spaceship tanks and structures to support that. Like, how do so since you're in that position and you're doing the CAD models, do you have a lot of freedom with how you design these things, or are you getting some sort of direction from upper technical directors and hey, look, we need it should be kind of this form or shape, or you really sort of like from scratch, like they're giving you the freedom to kind of come up with what you think based off the initial constraints and the preliminary constraints?
Yeah. So really, what it boils down to is what phase of the development do you come in? So I used to work at ULA. They built the rocket that the Dream Chaser, the vehicle, the spaceship is going to fly on. So you can come in at the conceptual phase where they're trading different concepts and very doing rough kind of hand calcs and different calculations to figure out what will work before they spend a lot of time and money refining that model. Or you can come in towards the end where you already have the general architect of the components, and then you're just adding like GD&T and adding fasteners to that. So right now, a lot of the models I've worked on, it's kind of like they initially designed a placeholder, like a very rough kind of geometry of what it's going to look like. And then like when I joined, I said, this is going to work, this is not going to work, based off like space limitations and types of fastener installation. You have to figure out all of that, and then I'll add some fidelity to it, and then I'll pass it on to a strength engineer, and he'll approve or disapprove the design. So really, when you join.
That's very interesting. So it sounds like as a mechanical design engineer, you're able to do your CAD modeling, but like you said, you still are working between different groups to make sure that what your design meets all the requirements structurally, thermally, in terms of avionics, make sure you're not blocking any signals. So that's pretty unique. That's really cool. Actually, that's actually what I want to get into more myself. So that's pretty inspiring, man. What do you feel like are the top 3 skills that you need in your position as a mechanical design engineer that you've seen so far?
Skills is primarily the ability to listen, actively listen. So you have to be able to listen to other people's opinions. But like CAD, for my job is CAD, being able to use the CAD software, because there's lots of different CAD softwares. And sometimes when you join a company, they're using a CAD software which you're not familiar with. So you need to be able to learn rapidly, listen to best skills or best practices in the industry. And also something that I think Syracuse did pretty good was Syracuse teaches you all these fundamental engineering knowledge. The toolbox, as Dr. Lawal called it. You build your toolbox there, your fundamental, your simplifications, how you're going to do free body diagrams and all that. You need to be able to kind of simplify the systems that you're working on in your job, simplify it down to like that. So also Dr. Lawal, he had this interesting exercise, which I think was one of the most beneficial exercises that I did throughout my undergrad was you need to be able to look at like a design and you need to be able to pull in different pieces of from that toolbox. So it's like, okay, you look at some type of a joint or something. You need to be able to figure out, well, I'm going to need to do this kind of analysis and this and this, and I'm thinking about this kind of material and these kind of fasteners. So you need to be able to like pull information from different parts of your memory. So
Mm, that's very interesting. I like that analogy because, like you said, we do have a large toolbox. We took thermodynamics, we took structures, we took aerodynamics, we took electrical, and like it sounds like you have to be able to discern at your specific position and your given project what information you need to what knowledge and skills you or what tools you need to solve the problem at hand. Because you can't be an expert at everything, so you have an information problem where you have to kind of hone in on what information you need. So that's really interesting, man. That's cool. That's cool. So you're saying listening skills, you said CAD skills, and then I guess your last one was kind of what was it, discernment or um, knowing what knowledge you need at the time.
yeah.
So uh, those are good answers. Those are good answers. Okay, so moving
I mean,
on.
there's other stuff, you know.
Yeah, oh, of course, of course. The
I was
list goes on.
I was listening to a few of the previous videos that you had. Very interesting interviews, but one that I really want to emphasize is like GD&T. GD
Oh yeah,
also
yeah.
analysis. That
I didn't
stuff.
even know GDT existed until I got to my job. It's weird how they never brought that out. At least I don't remember them bringing that up.
Yeah,
And,
I
and
just
at the end.
I wish that some of the universities take it a step further instead of
Hmm.
just like simple beam theory.
Yeah,
We would like teach some type of fastener analysis because I think fasteners is a could be a
that's
huge
a whole industry. Whole industry. Yeah, I didn't even think about fasteners. No, you assume that everything is just perfectly together. Like, wait a minute, how do things actually mate together? You don't just have a beam extending from a wall. You have bolts that connect beams to other
yeah,
beams and shear loads and you got to consider how you got to consider edge distances. You have a hole now. You got to consider edge distances
yeah.
and can you can design it perfectly, but can do we have the manufacturing equipment to actually build to the design requirements? So it's like there's so many things that they kind of left out. But I always say that that's why the most important skill that we learned was how to learn because
Yeah.
when every job you get to, you're constantly learning new skills and the process of every company is different. So you need to learn how to learn and be efficient. And that's what I'm most grateful for in terms of what I learned in Syracuse. But what do you think? What do you feel like you like the most about working for Sierra Nevada, or I guess they call it Sierra Space now?
Yeah.
What do you feel like you like the most about working there?
I guess what I like the most is yeah, I have to say the challenges. There's a lot of challenges, technical challenges, um, schedule challenges, cost challenges. There's a lot of aerospace is it's a unique field because you're launching something on the top of a rocket that's going many times faster than the speed of sound. So it needs to react that kind of load. It needs to be lightweight because there's a cost per pound to send payload up into space. So it needs to be lightweight. Usually there's strict deadlines, especially if you're sending food or astronauts up to the space station. You can't be late because otherwise you have astronauts stuck. So tests need to happen, and there's
Yeah.
certain deadlines that you have to windows of opportunity that you can do that. So it's and then you're working with very very brilliant people, very smart, very experienced people. So you're always learning. So I really like that about this job as well. And it really makes me think, and it challenges me. That's what I really like. And you're also pioneering the space industry. I mean, there was a time when humans were only on like a little island or continent, and they had to kind of overcome their fears and kind of challenge life, challenge themselves, and explore. And I feel like we are we're just starting that. I mean, we've already gone to the moon, but we haven't gone to Mars yet. And there's other places that building another space station, which some companies are doing, and I think we're kind of like at the beginning of that. So it's really, you want the future generations to look back and kind of be inspired by that. So
Wow.
it's a really exciting time to be alive.
It really is. I totally agree with you. Like we as human beings, we by nature been very curious and adventurous, historically speaking, and we've always explored new landscapes. And now space is our next sort of frontier. And I like what you said, like we've explored a lot of Earth, and now we're trying to get to Mars. And that's really cool that you said like your job is challenging because I know some people who they have jobs in engineering where they don't feel like they're challenged or they don't feel like that it's engaging. So I'm glad you said it's challenging and I like the you were describing, I guess, about how you have these constraints because you guys have to get payloads to astronauts. So it is like life critical situation. So you are having an impact, and that's very interesting. I didn't even think about that because I don't work. Um, I work with drones, so there's no people on board. It's a little bit different. We do have a certified plane we're putting out, so we do consider like obviously civilian safety because we have to make sure the aircraft don't fall out of the sky. But that's cool, man. I didn't and like you're like really are like a rocket, a rocket engineer. You're making these components that are literally going to space, and that's cool, man. I really respect that.
Yeah,
Um,
and just want to add on, I guess, an opinion about what you said about there are some engineers who don't feel like uh, it's like a challenging field. It depends on the kind of curriculum that you go into. Like there are development programs where you're developing anything, or vehicles, drones, spaceships, and then there's um, other kind of like maintenance kind of fields. So you kind of have to figure out. I mean, it's kind of hard coming out of college because you just want to, get a job, anything will
yeah,
come.
yeah,
Like I get it, but
just get a job.
you always need to be looking kind of in the future, figuring out where you want your life to be. Do you want to just, as Dr. Davidson gave another great life tip, and he said, do you want to be always challenging your career, learning more, advancing technology, or do you just want to collect a paycheck and
Mm,
comfortably? So you have to assess what your goals are for your career, and you need to make that decision and kind of apply like that.
I agree. I agree with that. I don't even that's great advice because, like you said, I do know people that are just kind of collecting a paycheck, and for me, I can't do that. It's like I gotta like what I do, and I'm always trying to learn new skills. I'm always trying to figure out, um, what trying to push myself. So that's great, man. I respect that. I always try to push that towards young people. Like, make sure you actually love what you do, and not just
Yep.
try not to don't become complacent. But to the flip side of everything, there's always pros and cons. What do you feel like is, um, what is the something at your job that you don't really enjoy doing, but you kind of have to do, or what is it that you like the least about working at this specific corporation?
Um, something I don't like is unpaid overtime.
That's real. Money.
You know, the previous CEO of a company said, 10% unpaid overtime is healthy. And it's like, healthy for who? But aside from that, which I strongly believe, I sometimes I don't like the speed of how some things go, processes. I feel like I some stuff takes longer. And
Yeah.
I understand it's an aerospace field. Stuff is very, very critical. Otherwise, you have huge explosions.
Yeah.
You can lose lives. But there's some stuff where processes could be sped up a little bit
Oh, for
faster.
sure. For sure. That's interesting that you made that. I haven't heard anybody make the comment yet about overtime. I haven't had to really work overtime, but that makes sense. But that's one of the most common criticisms I hear: the process and how slow things are at big companies. You know what I mean? So, how big is your company? How many do you know approximately?
Actually, I don't know the size of this company. It's a fairly small and young
Okay.
team that works in the mechanical engineering.
Okay.
But I'm not sure.
Yeah. Okay. I know my company's like over 10,000 total. And there's all this red tape for whenever you want to make a design change, it's like you gotta get this signature, you gotta email this person and call this person to present it in this meeting. But that just as a company gets bigger, that just kind of happens. That's just part of like the residual effects of that. But I agree. But like you said, like the industry that we're in is very unforgiving. There's no such thing as a small mistake in aerospace. You know what I mean? You you make one small mistake and it's life critical. Everyone dies on an airplane or the rocket ship. So you kind of have to have a little bit of wisdom and kind of understand, like, okay, I kind of understand why you know we have to move slow sometimes before we
And
make.
the larger the company, you know, these huge like 50,000 employee companies, of course,
Oh yeah.
the slower it's going to be. And then you have like your design in like Huntsville, Alabama, and then you have your like analysis in California, and then like you know, there's a time difference which could
Mm,
by a couple, like a day or two. There's communication, multiples, and I understand, you know, there needs to be multiple heads, like the experts, kind of signing off on these structures and everything. But like in terms of like really some of the manufacturing processes, I think could be a little bit quicker. There needs to be,
mm,
I think, you know, a little bit better training, a little bit less, and you know, with smaller companies, stuff gets done a little bit quicker, but with larger
yeah.
companies, you know, stuff is a little slower.
Very true. Very true. Um, so moving on, what do you think? And it sounds like you guys are making some pretty cool products. What's the coolest thing you've seen so far? Are you near the manufacturing floor? Do you have visibility or like? But anyway, what's the coolest thing you've seen so far first?
I sit probably maybe a half a football field away from the actual spaceship, so I see the actual.
What?
I actually see the installation of composite vehicles, so I see all that being assembled and installed. So, you know, that's really cool. There's a couple of vice presidents in the companies that are actually they're ex-astronauts, so I get to
Oh wow.
see them around. I don't want to talk to them too much because I don't want to waste their time.
Waste their time.
But you know, I guess in terms of like my career, I've seen when I was at ULA, I was in the factory, Decatur, Alabama factory, and I got to see Atlas V rockets being assembled, you know, all the way from plate, which is just, you know, big sheets of aluminum plate, machine that they had the machines in house. They formed the panels, they welded everything, they assembled all the barrels, the tanks on top of each other, and they sent it out the door as it's a complete booster. So I've seen Atlas V, Delta IV, Centaur 3, and the Vulcan, which is an excellent launch vehicle.
Wow.
I actually got to work on that. I was one of the design engineers for that. So I've seen these huge rockets, and it's really cool. I encourage anytime that there's like they're handing out tours or to get over to the launch pad to at least see a rocket launch. I
Yeah.
definitely encourage that because, you know, seeing it on a video versus like seeing it in
Seeing it
person,
in person, it
it's
must be.
it's completely different. It's an experience that you just don't forget. So
Wow. Which spacecraft are they making in the plant that's closest to you? Are you allowed to say the name of it?
I mean, the spacecraft that they're making it's the Dream Chaser vehicle. It
The
looks
Dream
like a
Chaser.
space shuttle, but it has deployable wings. So when it sits on top of the rocket inside of the fairing, the wings are like tucked in, and then when it comes in for reentry, we're not pursuing like, you know, the SpaceX or the Boeing Starliner, where it's just like a pod that uses parachutes and drops. The Dream Chaser is actually a vehicle that where wings deploy and you actually can land on a runway, because there's, you know, the advantage of that is, you know, when you drop this pod in the middle of the desert, in the middle of the ocean, you know, you need to send in a crew to at least
Yeah.
find it. You know, they
Yeah.
know the location of that, and they need to get it. But with the spaceship, they can land and send in vehicles, make sure it's safe, and get these lab experiments off. It could be time critical. I mean, you
Yeah.
know, there's rats and stuff that they test up there. You don't want them to sit on in the middle of nowhere for a long time.
Wow. That's pretty cool. I didn't know that. I don't really know too much about the Dream Chaser, but that's pretty cool that you have deployable wings. I know SpaceX, like you said, they do the parachute. They were trying to do the whole rocket engine landing, but I guess they scrapped that. Maybe it was too complicated. Um,
Well,
for
SpaceX, they actually, yeah, they land their boosters, but
the boosters, yeah, but not the
the capsule at the top, I believe they land that, or they just drop it down with parachutes. So
yeah, yeah, that one they dropped with parachutes. Wow, that's cool, man. That's super cool, man. Space stuff.